Okay, this is our final topic for lesson 4. We're going to be talking about compound functions. And so let's take a look at those 4 functions we named in the last section. We have f, g, h, and j. And we just talked about how we can use that notation to, we could say something like f of 1, which we write like this, f of 1. And it means just input 1 into the function f. We also talked about how we could perform operations on functions. So like we could say f of x times j of x. And it just means we take the information of f and we multiply it by the information of j, using just our typical expression operations to figure out what the answer is. So now we're going to talk about what this would mean. So the way I would say this is f of h of x. So f of h of x. I'm going to write that right here. F of h of x. And this is an example of a compound function. In other words, this is a function within a function. So I'll actually write that too. A function within a function. So there are a few definitions you can write down in your notes as well. Function within a function. But what does it actually mean? Well, if I had just f of x, I know that that means that I have a function with a variable of x. If I change that and say f of 5, it means that anywhere there was an x, I'm now going to put a 5. Or maybe I should write it like this. Wherever there was an x, that's where I'm going to put the 5. So I go back into the function and I put a 5 where there was an x. So what I am doing here, instead of putting an x in the function, or instead of putting a 5 or a number inside the variable, inside the function, I am going to put a function inside another function. I'm actually going to stick h of x into the spot where x was. And that is literally what I need to do to simplify this compound function. So I would say I have the function f of x. That would be 2x plus 5, right? Looking up in the top left. 2x plus 5 is f of x. When I wrote out f of h of x, what I did is I said anywhere that there's an x, I need to stick the whole function h inside. So wherever there's an x, I'm going to now replace it with h of x. What's h of x? Well, it's just 3x. That's what h of x is. So instead of x, I'm going to get rid of that and I'm going to put 3x. So 2 times 3x plus 5. It's like the f function ate the h function. That's kind of what's happening here. You know the child rhyme, like I know an old lady who swallowed a fly, I don't know why, and then she like swallows the spider to catch the fly, and then she swallows the bird to catch the spider. So she's like trying to, and it always like turns out really badly because she like dies at the end. It's a really morbid child song. So that's kind of what's happening here. We have a function that's eating another function. It's got the h of x inside of the f of x. And so wherever there was a variable, I replace it with the function that it ate. So let's take another example. By the way, in case you were wondering, this does simplify. I would share that 2 and get 6x. Now in case you're looking at your screen and wondering why I'm not using the distributive property, like why do I not say 2 times 3 and 2 times x? Well, remember that the distributive property distributes to terms. Terms are separated by addition and subtraction signs, so 3x is just one term. So don't over multiply here. You just multiply once. 2 times 3x is just 6x. Okay, so let's try another example. So we just did f of h of x. I'm going to just erase part of it so that you can compare them. And let's do Let's see, what would be a fun function? How about we have the j function eat the f function. So how would I name this? It would be j of f of x. That's how you would describe this. J of f of x. I'm going to erase that though, now that hopefully you can write it down in your notes, but I don't want to confuse us as we're solving. So what does that actually mean? It means that I have the j function, which is just x squared, but it means that it kind of, instead of the variable, we're replacing it with the whole f of x function. Well, what is f of x? 2x plus 5. So instead of x, we're going to get rid of that, and we're going to put 2x plus 5 in there instead. So the result would be 2x plus 5 squared. And that would be a compound function. Again, we say compound. Compound usually means there's more than one of whatever you're talking about. Like a compound word would be 2 words in 1 word. A compound function would be 2 functions in 1 function. Instead of the variable, we take it and we stick a whole other function in. Or you can think of it as being the old lady who swallowed the fly, and so we put, it like eats the whole other function instead. However you would like to remember it, that is what it means. Now, there's something important, since we're talking about notation. Notation always means symbolism. Like symbolism we need to agree on so that we can all talk the same language. That's what notation means. So that we're all talking the same language, so that if you see somebody referring to compound functions in the future, you want to make sure that you know what they mean. What I've written on the left is an accurate way of describing a compound function, but it is not the only one. In some textbooks, if you're talking to certain mathematicians, instead of writing it, well actually, let me write it here. I'm going to write it with a different color because I want it to stand out. So we'll make it blue. So instead of writing it as f of h of x, they use this little notation that looks like this. F with a tiny little circle, which represents of, f of h of x. It means exactly the same thing. So there are 2 different ways of writing the same expression. So if you see it with all these parentheses, f of h of x, you can see that the h of x got stuck inside. Or if you see f of, where that little circle represents the word of, f of h of x, either way, we're talking about the same thing. So that's just an aside. Make a little note. I will make sure that in your work in class, we look at both examples so that you're familiar, so it doesn't throw you off if you see someone describing it one way or the other. So that wraps up our discussion of function notation. We, again, just in review, I always want to kind of bring some closure at the end. We have talked about what function notation is, naming functions according to a letter. F, G, H, it could be M, it could be Q, it could be Z. It doesn't matter what letter. But we always write it as f of x. So we name the function and then we name the variable that's used in the function. So that's what function notation is. We talked about how function notation allows us to write something like f of 1, which would say, I want you to input 1 into the equation of f. It also allows us to perform operations between functions, so f of x plus g of x would be an example. Or we can actually use it to describe compound functions, which is what we just did in this video. So make sure you have all those notes done, and we will talk about it more in class.